Hey Islanders, welcome back to another episode of Islander Robotics. As always, I'm Will, and today's going to be a fantastic video. Reason because we're going to be talking about sorting algorithms within Python, but not just any sorting algorithm. I'm going to be showing all of you how to implement the amazing algorithm of merge sort. So sit back, relax with your favorite snack, and let's get started, shall we? Alright everyone, I hope you all enjoyed that little bit of a time lapse, and please let me know down in the comment section down below on what you all think about the time lapses, the music, all that stuff. I really want to hear all your feedback, and so that you can all get a better experience while watching these videos. Alright, but now back to the code, where I just want to say in no shape or form is this the only way to implement merge sort. I mean, on this channel alone, this will be the second way to actually implement merge sort. Alright, and the reason being is because I actually did a video a while back on the theory as well as how to implement merge sort into a Python code. I did all that, but that implementation is completely different than what the implementation of today's video. I highly do suggest going to check out that video, because that video I do go over the theory on merge sort. And this video we're not going to be really going into the theory on merge sort, but I also have to give props to where I got this, essentially this version of merge sort, because I did make changes, my own changes for merge sort, but I really just want to point out where I got the original algorithm, the original format for this code, which is from Dive Into Algorithms by Bradford Tuckfield. Link to this book will be down in the description bar down below. It's a great resource. But in that book, he went over merge sort, as well as there's also another way to do merge sort inside of Python, and you could just done sorted, and then let's say number less. All right, that's another way. It does the same exact thing. However, you're gonna notice throughout this code that the reason why I couldn't do this is because of how I want to take two lists, combine them into one, and then be sorting it all over the place while keeping those two lists together. All right, so essentially I'm going to be wanting to zip them together so that I can move the numbers around while the strings stay with the numbers. You can't do that with this Python method. I mean, if I'm completely wrong, please go on down ahead in the comment section down below and point out what I missed on this built-in function of Python. But we're going to continue on to talking about the initialization of this class. All right, I'm just going to delete this right here and there. And what I decided to call this class was Islander sort. All right, really just because, why not? And then def init self number list string list equals none. All this we've already gone over inside of the original video on Python classes. All right, at the way beginning of this series. This is something that you probably have all not seen. This is so string list is considered in Python, well, this class, a non-necessary argument, meaning you can put in nothing right here and the class will still run because we have it equal to none. All right, and really, this is just so that for those of you that want to actually operate this code without having to actually put in a string list, then you all have the possibility to do that, because all the code will be down in the description bar down below, but string list is going to play a huge factor for my application. All right, and also gives all of you an option to actually completely neglect this. And we actually do this by saying if string is num, self.data equals number list. All right, so the data is just equal to this, and we say self.both equals false. Don't worry about the false right now. It's going to play a factor later on in today's code. And then else, meaning that string is not equal to none. And none's really just like it's pointing to nothing. It's taking up memory, but it has no value inside of the memory. All right, so after that, this else is basically when the string doesn't equal none. And when the string doesn't equal none, basically what we're going to do is we're going to say self.data equals list. So this is really what we're going to be doing for this line of code on line 13. essentially it's going to be list comprehension. However, we're going to run a little bit of a twist on it where we're going to use a method. So this zip list, zip, number list, string list. It's from the compress module from Iteral Tools. All right. So what we're going to do is we're going to take number list and we're going to take string list and we're going to combine them together, zip them together, hence the zip. And throughout the rest of this class, they're going to be considered one list. So each index is going to, so index 0 of number list and index 0 of string list are going to all move around together. We're going to have to break these apart later, which is why we have the self.string as well as the self.number both equaling an empty list. Next thing we're going to talk about is the actual merging sort, which is actually going to be broken up into two functions. The very first one is going to be, ironically, it's going to be line 37, which is called merge sort. And before we actually continue on, if I just want to mention one thing, because if you're like me when you first saw recursion, you were probably wondering, how do I incorporate a recursive function within a Python class? The easiest way to understand it is just ignore the self, because if you ignore the self, it's just going to be like any other function where we have a recursive variable that we're going to be inputting, and we're going to have a base case that's going to cancel the recursive call, and we're going to have something that's feeding the recursive call. But before we actually get in depth on what's going on, our base case is really if we want to check if the length of data equals 1, and if it is, we're going to say new list equals data. New list is just an empty list that we create at the beginning. It's just going to be populated with the sorted array, and then we're going to be returning new list at the end, and then new list is just going to become lost in memory. All right, but new list is going to be returning back to the original function that this function was called from. But after that, if this if statement is false, we're going to continue on to this else statement, which is going to be feeding the recursive call. Really, 43 and 44 are kind of very, very similar, but at the same time very, very different. We're going to be taking data and we're going to be splitting it into two lists, a left list and a right list. And again, we're going to be using, before I finish that sentence, we're going to say left and right. Well, let's just start with left. Left is going to equal self.mergeSort, so this function that we're in, data, and we're going to be using list comprehension, all right, where we're going to be saying math.floor is going to be the length of data divided by 2. Let me explain some stuff. So each time, in order to get a left and a right, we got to divide this by 2, but there's a good chance we don't get an even number. Therefore, we're going to say math.floor, which comes from this math module right here. And what this math module does is say we have a length of, we have a list of length of 5. 5 divided by 2 is 2.5. But with the math.floor, we're going to take that 2.5 and bring it to the floor, which is going to be 2. Now, that's what the floor is, but what's this colon used for? So this colon stating everything up to that length or that index, all right? So if it's 2 in computer language, it's really 1 because 0, 1. So 0, 1 is going to get passed into here, but we still have a whole other part of the list from index 2 all the way up to index 4 that we have to deal with because only index 0 and 1 is getting passed into the left list. The right list is going to get the rest of that data, but because math.floor, and we're going to be passing in length data divided by 2, is before the colon, that means that from this number, so 2, well, technically 3 in this circumstance, is going to get passed in. So 0, 1 is going to go into left, 2, 3, 4 is going to go to the rest. So this colon means to the very end. All right. After that, we're going to be calling new list again, and we're going to be setting it equal to merging. But before we actually continue on to merging, let me just talk about that we're going to be passing in the left and the right. And this merging's really, I'm going to be going into it pretty in depth in just a couple of seconds, but we're going to be returning the new list back to the original function like I was talking about earlier. Now we're going to continue on to merging, which is the next factor of merge sort. And really what line 19, so notice we went from 37 to 19, and that's the next step of merge sort, which is we're going to be merging all the left and the right array, the right list back together. All right, and we're going to be doing this by saying by having two input arguments, left, right, and we're going to be creating a new list again on line 21, and then after that we're going to be creating a while loop. This min, length, left, length of right, really what we're saying, we want the length, we want to take the length of the left one of the left list and the length of the right list. Whichever one's smaller, that's the one that we're going to be keep an eye on, because each time this while loop comes back, one of these lists is going to get smaller, all right? And whichever one hits 0 first, that's when this while loop is going to break out. And how do we get these lists to hit 0? Well, if the left index of 0 is greater than the right index of 0, we're going to be going into this if statement, where we're going to say toInsert equals right.pop, where we're going to pop this index, and we're going to set it equal to this insert, and therefore the length of right is going to get smaller. After that, we're going to append this piece of data to new list. And then if this if statement is false, then we're going to go into this else if statement, where we're going to say we're going to be checking the left list at index 0 if it's less than or equal to the right index at index 0. And if this is true, then we're going to say toInsert equals left.pop, which is basically the same thing as this, but we're calling the left list. And after that line, we're going to be appending toInsert to new list. After that, there's a chance that one of these lists is going to be still going to be populated in some way. So we still have to take that data and add it to the new list. And really, we're going to do this by saying if length of left is greater than 0, then we got to create a for loop where we're going to say for I in left, and we're going to be appending I to new list. That's for the left list. Line 32, same idea, except it's for the right list. And then once we're done with that, we're going to be returning new list back to merging. But instead of coming back to merging, we're going to be going to where merge sort was originally called, which is this driver function right here, which is the same exact. It basically has the same purpose as the driver function in the main module, where it's just going to automate all the tasks within this class. So first line inside this driver function is self.data, and we're going to set that equal to self.mergeSort, and the input argument for mergeSort is going to be itself, self.data. All right, and then after that, we're going to be calling this self.split function that we're going to be talking about right now, which is on line 49. And on line 49, it's just as simple. We're just going to have an input argument of self, and if self.both, remember those true and false right here, false, true. This is so that the program can know if there is two pieces of data that we have to split, or if there's no piece of data that we have to split. If there is a piece of data that we have to split, then we're going to create a for loop where we're going to say for I in range of length self.data, and so when we zip those pieces of those two lists together, we create one list with two dimensions. All right, so that's how we're going to split it apart, is by separating the two dimensions into their single dimensions. Where we're going to say self.string dot append, and we're going to append the self.data of I at index 1. All right, so wherever this I is, that's where this first index is going to be, and then the second dimension of the index is always going to be 1. And that's how we're going to get the strings for the specific piece of data. All right, and then the number, same thing. We're going to be self.number.append, and we're going to be appending the self.data at index I of 0. All right, so you can really manipulate this however you want, but how that zip method works for the iteral tools is that you're going to take one list and turn it into, we're going to have one list that actually has two dimensions. And then if this statement is false, meaning we only have one piece of data, we're just going to say for I in self.data, and we're just going to append I straight to self.number. Really, after that is really the end of this module. Before we actually get over to the main module and implement this, we have to do some tests. Really, anytime you have a helper module, before you implement it into the main module of your software, you have to do some tests to make sure that the module actually does what you want it to do. All right. So with all that being said, how we're going to test it out is all the code from line 63 to line 76, where 63 and 64 we're creating the two lists that we're going to sort. And new list is going to just be a list of integers, and string list is going to be a list of strings, all right? And really what we're looking for in these test cases is are we able to successfully run this class without having string list passed in, as well as we want to make sure that new list is being sorted, and also the last thing we want to do is that string list is being sorted based off of the values of new list. So really the first piece of data is going to be data equals an instance of Islander sort, where we're not including string list. We're just saying number list is equal to new list. And then after that, so that this class actually gets automated, remember we actually created a function to automate this whole class. We're going to call the data.drive. All right, and then after that, you're going to see the outputs from data.data as well as data.number. Really what we're checking here is that data and number are both the same list virtually, as well as that these values are being sorted. All right, so if these values are being sorted and that data.number and data.data are basically the same, we can continue on to the next sorting out. Well, the next section of the test. We're going to create a new instance of Islander sort equal to data again, except this time we're going to say string list equals string list. All right, and then we're going to be calling data.drive again, and we're going to call an f string that's basically copy and paste from 68 and 69, but the difference is that 74 you're going to see new list and string list zipped together, and 75 we're going to see new list and string list unzipped, where we're only going to be seeing the values from new list, all right, sorted as well. As well as on 76, we're going to be seeing the values from, we're going to see the values of string list sorted based off of the values from new list, all right? So that's really what we want to make sure of going into these test cases. Depending on these test cases, will really depend on whether or not we're going to implement this module into the main module for the YouTube Keyword Planner. So with all that being said, why don't we come over to a terminal, and I really want to move me so that I am not in the way of you guys seeing what's going on. All right, so I moved myself on OBS. We're just going to go pop, Python 3, Islander sort.py, and why don't we check out the output. Right here is the output from data.data without the string values. And 0, 2, 3, 4, 6, 7, 43, 100, it is successfully sorted. And then data.number without the string is successfully sorted as well, and they're virtually the same. Meaning we are able to successfully sort our values, our lists. And then now we have to make sure that string list was sorted based off of the values of new list. So therefore, we can tell by two ways. First way is going to be right here, 0 and will are matched together. 0's up here, correctly sorted, as well as 0's down here, correctly sorted. And then will, if we remember correctly, when we come over to here, they are both in the same index. So that does work out. And then we're going to want to go through individually to double check, but from what I can see, we'll do what Bob, you with stuff that, and then 0, 2, 3, 4, 6, 7, 43. This was able to successfully sort our lists based off of the values inside a new list. So with all that being said, why don't we switch over to the new module and start off at... Alright, Islanders, I'm sorry. I'm going to have to cut this video short right here because I really want all of you to understand merge sort. Alright, in next video, I will show all of you how we actually implemented this code. As well as if you want to go down in the description bar down below, you'll see a link to today's code where it will be an updated version with this sorting algorithm added to the code. All right. So if you want to get ahead and see how this class was actually implemented into the main software, go right on ahead and click that link in the description bar. As well as really to those Islanders that have reached it to this point in today's video, you're all truly awesome. I'm so grateful to all you Islanders. If you have any questions, please do leave it down in the comment section down below, because merge sort is a huge thing to understand. You're going to be using this sorting algorithm a lot throughout your coding career, as well as this is probably going to be in your coding interview. Merge sort is a huge thing for many coding recruiters or coding interviewers. And with all that being said, if you found value out of today's video, as well as if you enjoyed today's video, or if you want to just help support this channel, please do hit that like button. It really does help tell me that you're all enjoying this content, as well as it helps the YouTube algorithm see that you're all enjoying it, which therefore the YouTube algorithm is going to try showing these videos to more prospective Islanders. For those Islanders that are not yet subscribed, please do consider becoming part of the Islander community by hitting that subscription button as well as that bell icon, so that you can really just become part of the community that teaches each other robotics through programming. With all that being said, Islanders, you're all awesome, and I'll see you all in next week's video. Bye.